All right, let's start for today. Let's take a look. Today, January 29th. What is our problem? All right, vertical order traversal of a binary tree. Okay, I generally like binary tree, so let's see what's happening here. Given a root, calculate the vertical order traversal of the binary tree. Original position x, y, its left right child of the position x minus 1, y minus 1, x plus 1, y minus 1, respectively. Huh? What does it mean? The vertical order traversal is a list of non-empty reports for each unique x-coordinate from left to right. Each report is a list of all nodes at a given x-coordinate. X-coordinate. Huh. So we're talking about x and y coordinates? Family sorted by y coordinates from highest y coordinates to lowest. If any two nodes have the same y coordinate in the report, the node with the smallest value shall appear earlier. Alright, let's look at the example. Don't quite understand. The root node is at position 0. So we're talking about root node is here, right? The node at the nodes with value 9 occurs position minus 1. Okay, this is 0, 0. Alright, okay, this is 0, 0. Minus 1, minus 1. This one we saw. 1, minus 1. 20 will be 1 minus 1, yes. 3 is 0, 0. 15 is 0 minus 2. 7 will be 2 minus 2. Okay? So, what do we return? We return the vertical order. 9, 3, 5, 27. Oh, vertical order. We go from the x-axis. Okay, let's read it again. For each node, its left and right child will be x minus 1, y minus 1, x plus 1, y minus 1. Yes. So it's a list of non-empty reports for each unique x coordinates from left to right. Each report is a list of all the nodes. The report should be primarily sorted by y coordinates, so first appear first, 315. And if two nodes have the same value, same y position, so if they are at the same, how could they be at the same y position if it's on the, alright, could they be on the same y position? Yeah, I think so. This is a y position, right? So each level, I don't think they will be, oh, hold on, this is on the same y position. Yep, these two are on the same y position. Okay, it's possible. The node with the smaller value should appear first. Okay, so this one, let's try to do it manually. I'm using my paper, pen and paper. The best thing that you can use to do this type of problem. So what we're looking at is here, this thing. So the traversal will be 4, and then, ooh, what is that? This is 0, 0, minus 1. So this will be 0 because this is on the same line. So there will be 2 will be by itself as minus 1, and then this is going to be 1, and then 5 first, and then 6, then 3, then 7. Let's see if this is how I expect. 4, 2, 1, 5, 6, 3, 7. Okay, I think we got it. Alright, let's see how do we solve this. I mean, we can traverse it. We can traverse it and give everybody their coordinates. And then, as we give them their coordinates, we put them in this. So we create, I shouldn't say create, let me think. But BFS, But first we go layer by layer. Alright, so go a layer, and then we go a layer. And then at each layer we can get their, so we store their coordinates for each one, and then we go to the children and we put the correct coordinates there. And when we have the children, we put the children in there. Right, or put the children in the corresponding. We don't know how many. We don't know how many there are. Well, we can use a dictionary, so we don't really worry. Right, we don't worry how the order is. Okay, we use a dictionary, and we use the key will be your x coordinate will be the key, and every time we find one, we put the value inside. Now the question now is how do we? Oh, it's fine. We can put a value in, and we can say we put the y coordinate first. It's going to be a tuple. That's right. Every time we push in, it's going to be a tuple with y coordinates first and their value second. And then we can sort it. And once we sort it, we can specify the key. So the key, we're going to look at the first value first. And if the first value is the same, which means the y coordinates is the same, then we will sort based on the second value. Okay, I think this might be the solution. At least the simple, naive solution. Let's go for it. We just did this yesterday, so we can just copy one of our templates. We have a template here. And I'm going to open, oops, that's not the one. Open the template. Alright. This is our thing. Oh, that's way too big. Hopefully it's still visible. Let's get this a little bit smaller. We don't need it too big. Alright, that's much better. Okay, delete whatever is in the template. Put in a new one. Now for this type of problem, I'm not going to test on my locally because it's a little bit hard to. I might have some pre-written code to transform, because LeetCode has this convention to how this is represented. And I have written something to convert this into a tree representation in my code, but usually I don't want to do it because it's just not necessary. Okay, anyway, so what we're gonna do, we need a dictionary. So the dictionary will be, let's call it rest_dict. So we know this is a dictionary for the results. And it's going to be a default dict with list. And we're gonna, from collections, import default dict. Alright? Okay, so this is our dictionary is ready. And now we're going to traverse it. And then we want to do, okay, let's just do it the right way. Let's do the right way instead of the wrong way. We're going to say a queue will be a deck. And we're going to push in. What do we push in? We push in the coordinates and the value. So what we're going to do, we're going to push in a coordinates. Yeah, coordinates will be 0, 0. That's the first. And we're going to push in also the value. So it's going to be root.val. However, root could be, so if not root, we're going to return this. I'm pretty sure. Let's double check. Yeah, these edge cases are, let's scratch your head against these edge cases. Yeah, I think this is right. It's gonna be M. Oh, hold on. Ah, my bad. It's not even. You don't have to consider this. You don't have to consider this because the root is guaranteed to be there. So while Q, so I'm gonna do this traversal. I'm gonna pop. Actually, it doesn't really matter which way you do, but I think breadth first is easier to write. Maybe easier to write. So I'm going to pop x, y, and val equals q.pop left. And then we're going to push new ones in. If, oh, why do you put a val? We need to check on the parent, on the children. So we're going to put node. If node is not none, q dot append. When append, so no, node is not none. Dot left. Left is not none, so we're gonna push x gonna be x minus 1, y going to be y minus 1, and it will be node dot left. What is this? Right? If node, we can actually copy and paste this. I think that's fine. I'm gonna copy and paste this, and I'm gonna change. This is gonna be right. And I think it's not going to be x plus 1. Right. And now we're going to handle x and y. So we're going to do rest dict x, that's our key, dot append. So we're going to append the y first, and then node dot val. Okay, so that's that. So after traversal, we're gonna handle the rest dict. So we say rest equals this, and then we're gonna do for key in rest dict dot keys. And we need to sort it because we need to follow the order. So I'm going to sort this. I'm going to sort the key. Yeah, it's impossible to know how. Well, it's actually number of nodes. You actually know. You actually know the number of nodes in the tree. So the maximum width is 1000. So you just do 1001. So we don't need a default dict. All we need is this times 1001. I said 1000 because, wait, hold on, 1000. Yeah, maximum is 1000. See, it's 1000. So, and that's 0, 0. Oh, but hold on. 0, 0. Okay, so if the 0, 0 is here, what extent? That'll be 1000. 0 to 999, right? Or 0 to minus 9. So it's going to be 2000. It's actually 2000. So 2000, right? 2000. 1000 here, and 1000 on the left, 1000 on the right. That should be sufficient. And that's actually not 0, buddy. It's going to be this. It's going to be like a 4 in range. My bad. In range 2000. There we go. So we created. It's not rest dict. It's just going to be rest list. Change it. But essentially it's the same thing, right? It's the same thing. And we say, oh, and then we don't need because it's already sorted. Perfect. So we're going to say for let's say L in rest list, right? We just need to sort this. We're going to sort it in place. L sort. We're going to say key equals lambda. So we're going to pass in, this is going to be a tuple passed in. And then we're going to sort by tup 0, so which is y. And then if it's the same, we're going to sort by tup 1. I'm actually not sure about this syntax. Alright, I'm not sure. I might be wrong, so let's double check on here. Can I make this bigger? Oh yes, oh yes. Oh, I didn't know you can get it this big. Perfect. So we can do, let's just trial. Let's say 1, let's say it's 2, 1. This color is not good. 2, not 2, 1. Let's do 2, 3, 2, 1, and then 1, 3. Alright, let's do this. Alright, so we're gonna do a.sort key equals lambda top lambda top 0 and then top 1. Positional argument follows. Okay, that's probably not correct. Let's see if we put this so indicate it's oh, this is right. 1 3 2 1. Okay, yeah. So I know. So it is not right. We have to put a parentheses. So we sort it and then we can return res list. All right, let's check. See if it's correct. We have checked this. Now I'm gonna check the ones here. All right, let's take a look. Ooh, what the heck? This is wildly not correct. Oh. Oh well. Oh no. Yeah, that's not correct. $3.15. Oh, and then we have so many. I have to still use. Wow, it's very off. Very, very off. Man, one of the numbers is not even here. Oh, I think I know why. Oh yeah, this is a wrong idea. Zero is always here. Oh my god, so I have a bunch of on the other side. Yeah, let's just double check. We have bunch on the other side. Yep. Oh my. This is not right. So we have to sort it. So we have to sort it. It has to be a dict. It cannot be a list. So it has to be a default dict. And it can be a list inside. This is all the same, but yeah, we have to go res equals this. And then for key in sorted rest dict dot keys. So we need to sort this. Rest. So we're gonna say. So we're gonna sort this, but at the same time. So we're gonna say rest dict k dot sort. Yeah, we're gonna use the same sorting here. That's fine. So we sort it, and then rest dot append. It's not gonna append the entire thing because we only need a value. We only need a value. So it's gonna be v for v in res dict k, and this has to be a list. I'm gonna return res. Alright, this is going to be very different. Yeah, we realized that it's not possible to do it the other way. What the actual... Oh. It's going to be a tup. It's also a tup. Tup 1. Which line? This line. Yep, this one's correct. Double check on this one. And we will run a few more if we are up to it. This one. Not gonna work. Oh, what the hell? Five, 6, 1. Oh, because y is decreasing. So if we have to sort reverse, the biggest at the top. Oh, wait. Oh my god. Hold on. Hold on. Hold on. Hold on. It has to be. Alright, so if we don't change it, it's going to be biggest at the top. But we're going to sort reverse, so 6 will come before 5, which means what we need to do is to sort regularly, right? Sort still smaller goes on top, but we need to reverse it. So instead of putting y in here, we need to put a minus y. And to put a minus y, and we still sort regularly. Okay, let's try it. So we're going to put the minus y, which means all of them will become positive values. And then the smaller will go. Okay, so we still go, so it's no reverse. It's just regular. Oh, what the hell? Oh, just get the full thing. Alright, this shall be correct. Alright, let's try some just random stuff. We add a few null here and there. We add some more value, some more nulls, and then we probably add a null here. So this is a convoluted, very convoluted. Let's take a look, see if this one produces correctly. I think we have correct, and there's one more type. I think it's 1, no 2, no 3, no 4, no 5, something like that. So we're testing like because it's a tree, so it can be very slanted to see. Okay, this one produces correctly. How do we do on the other side? Is it the 2? Oh, look at that. We got it. So it should be a similar thing. 5 plus 51. Okay. All right, submit. Pending. Accepted. Good. We got it. We got it. Not too bad. Not too bad. This might be the official solution. All right, so let's write about it. So not too difficult. A problem as long as the correct data structure is used. We traverse through the entire tree, either BFS or DFS. I don't think it matters. We also record the coordinates of each node, and each node we visit, we place the coordinates. We place the coordinates. Now we place the node in a dictionary. In a mapping. I call it res dict. Put it in a mapping according to the node's coordinates. We use the x coordinate as the key in the mapping and y coordinate as the first. Actually, it doesn't matter first or second because we can determine how we want to sort. So I shouldn't say put a y coordinate. So we put x coordinate and the value is a tuple of y coordinate and the node's value. So after traversing the tree, we continue to process the mapping. Now for each value, which is a list of tuples, we need to sort based on a y coordinate first. Actually, not y coordinate. type of minus y coordinate. And note that it is crucial to put minus y coordinate. That is to make the y coordinate positive. Based on the minus y coordinates and node values. Since we use the minus y coordinate, we can sort based on both in ascending order. Finally, we take the values out of the mapping into a new list according to the order in the keys. Or traversal is on. That's so be on. On, and then you have to do. So this is on. Let's have all the sorting, and then so we do this, and we also need to do. Let me think. What's the so keys is the x coordinate, which is supposed to be what is supposed to be. So shouldn't it be like 2 to the log n? Right, 2 to the log, so it's n log 2. So it's n. Right? Is it n? No, it's 2 to the. All right, come on. So we know it's going to be log n on depth. So a total number on the last one. So that's like 2 to the 1, which is log n minus 1. So it's log n minus 1. So 2. So n minus 8 n divided by 2, something like that. N divided. So it's still n, right? So we have on is this plus n. N is have to go n times on here, and then when it's sort will be a log n, right? Well, because it's gonna be we sort each one is the height, like maximum is the height, so it's log n. It's been log n, log n, something like that. Let's call it log n. So it's gonna be a upper bound. It's actually upper bound should be higher than log n. And plus we'll have the append, but that's a plus. Let's just call it n log n then. I do not want to. Yeah, I think that's just n log n. Let's just call it n log n, which is on log n. Based on the runtime, it looks similar to on log n. We run at 32 milliseconds and 80% ranking. All right, I don't think there's anything more I want to add. Let's just go directly to the official solutions. Let's see if anybody leaves anything for me. Yeah, I remember when I did that. No solution, no solution. That's fine. We'll just look for it. Wait for it. It comes out. It's gonna be a medium question. Huh. It's a hard question. Really? Oh, I did it! Did it last year. No, just a few months ago. I think it has appeared again. Oh, it almost did at the same time. This must be the same. I probably use the same. Okay, I'm more interested in what I used in the past. Let's see, what did I do in the past? In order. Rest dict, blah blah dot append. Default dict. Oh, I use a default dict and another default dict. I think I was sorted dot keys. I use it 2 times. Yeah, I can see that. I can see why I did that. Which is, I mean, it's fine. It's not biggie. What's the second method I used? Probably is this one. Oh, I used the chain method. I don't even remember what chain method is. But in order, so in order, return chain method sorted. So x dot keys. Reverse, yes, because, hold on, what's x? X is x. Why do you reverse it? Oh wait, this is the x, this is the y. I sorted y in reverse, which makes sense, and each y. And then we put x, y, that is the x, y, we have the values, and we sort the values. And then we break them out into individual, and then we chain them. So we chain, I don't even understand what I was writing there. We chain something for, I forgot, what is chain? Oh, it's append. Oh, yeah, I remember. Chain is to basically append iterators together, because this came out is an iterator. Could I do the for? No, this is, break it out, chain it. Hold on, I still don't know. Chain first iterable until it is exhausted. Okay, and then proceed to the next iterable until all the iterable exhausted. So which means what we're saying is for y in sorted, I've sorted this. Oh, so we have sorted this. Okay, I think it's break it up. Break it up. So what do we have here is for an x, the key, right? And we have a bunch of y's. And then we go into the y's. So we sorted the y's. Go into each y. We sort it out, put it in here, sort it out, put it in here, sort it out, put it in here, right? So this one is, so it's flattened. I think this is what I'm trying to do. I was trying to flatten the list of lists, because the output is a list of lists. So this is a list, and then we have a bunch of lists inside, and then we have another list. So I use this to destruct it, so the outer gone, and then I use chain to basically chain them together. So it'll be, so chain, so for each x, if I do chain, it's going to iterable, so we will just do this. I think that's what it means. So chain and iterable will just turn it into individual. So we get them into individuals, because this is going to be a gigantic list, right? It's a gigantic list of list, and then we break it open so the internal list comes out, and we need to chain them together. Convoluted. I don't like it. 5 months ago, I don't like it. So we've done this before. This is an old question. Tree map using only priority queue. Have I read this before already? Oh Lord, monstrosity. I'm not gonna read you. Tree map. Now, I guess there are a lot of ways to solve this problem. I mean, my method is definitely not the only way. You know, when you look at this, it's like, why? Why you do this to us? Add some comments. By the way, what is a tree map anyway? Something Java specific? Tree map and priority queue. Huh. That is interesting. All right, let's see. Some say using only priority queue. Oh, we have implement priority queue itself. And the comparator, you have to put your comparator together. Okay, so you have this rule and each node. So the signature is also different. All right, I want to try to understand this one. So it builds a priority queue. So if x is smaller, so we compare on x. And y we go big. Value. Okay, so that's fine. So we create a new list, new array list. Vertical traversal helper. So this is just, yeah, this is just a DFS, nothing special. So we basically say we're gonna do DFS, and after DFS, we're gonna pop out from the priority queue. So it's not an empty priority queue pop out, and then we're gonna take a look at the previous one. If the previous one is null, or the previous one and the current one is the same, then our current one will just keep adding, because we have the same x value, because x value will be the first to check. Yeah, x value is first to check, so we make sure that each time it pops out, it's always the smallest x that pops out in this priority queue. And after the x is popped out, we check if it's the same. That means we're still in the same record. We just add the new value. If it's not the same, or if the previous is no, that's actually the initial. I think that's the initial position, right? It's null, so you need to add a new one. So we're going to say if previous is not null, then res.add L. So that means, so if the previous is null, then we just add a new. If the previous So we create, so wait, if the pre is not equal to null, we add a new list. And then we create a new list. So we always have a list. Always have a list out. And if it's not the same, and if the previous is, no, we just create a new one. So why do we even need that? Because the previous will be null, and as when you start. When you start, the previous is going to be null. So you're going to create L no matter what. And you're going to have to create L because you set previous to null. So when you go inside, you get P out, previous will be null, and this will not execute. So it will execute this. So you will create an L no matter what. So this probably just initialize. And then you keep adding until it's not the same. Then you put it back in. And then, okay. Perfectly. That's perfectly fine. If we want to implement this in hours, we have to... I have done something similar before, which is we need to add some magical method inside here. But we need to write in a wrapper around, which actually I want to try. Yeah, I want to try this one. I want to try this method. Let's see, some Python q plus hash map. This is looks different. So that's traversal. Add new. The left, no, the right. What the hell is S? Stand. I don't like it. It's not. Yeah, I like Mike because I can understand it. Oh, good question. Premium account. Alright, I think I just want to try to implement the priority queue. I personally like priority queue because Python has something called heap queue, so I'm going to try that. It's going to be same thing. So what we're going to do is we're going to copy this code. Alright, and then we're going to write a, let's say, class, we'll call it a wrapper. So in this wrapper, hold on, should we pass in the, is that how we write it? I don't need this. I actually forgot how to write the wrapper. Node. It's gonna be a tree node. So we just need self.value equals node.value. Okay, we're still gonna do x and y. So x, y gonna be it. Self.x equals x, self.y equals y, and now we're gonna just do a def less than self other. So I'm gonna say, we'll basically use the same logic. If self.x is smaller than other.x, I'm gonna return -1. And if self.x so we have x, so fy is larger than other.y, return -1. So if these two are all the same, so x comes out first, and the smaller y comes out first, and then we're gonna return self.value smaller than self.other.value. Hold on. I think he has more. Oh. I also think this is gonna be false. Probably just false. But -1 shall work. Alright, so we're gonna say this is inspired. I'm gonna say this later. Say priority queue, PQ. This, and we're gonna put PQ is going to be wrapper root 0 and a 0. Right, this is our PQ, and now we have a regular queue that's used for traversal. How about we write? Yeah, let's change it. Let's def DFS, just for fun. Just for fun. So DFS, we're gonna get node x y, right, and then we're gonna heap q dot heap push, and push in is going to be a wrapper node xy, so we push it in, and then we're gonna say DFS. Oh, and then we say if node, right? So DFS node.left, left will be x -1, y -1, DFS node.right, x +1, y -1. So we do that. After we do that, I'm gonna call DFS root 0, 0. All right, so after that, PQ shall be populated. Now, after PQ is populated, oh, I think I put it wrong. I forgot to set PQ in here. We're gonna pop things out. Right, so every time it came out, we give it a list. Yeah, we do need a list. List is this. So when we pop out, and we say, yeah, I think a pre-x equals, let's put a none, right? And so while PQ, when I say wrapper equals heap q dot heap pop PQ, right? And then I'm gonna say x val equals wrapper.x. I don't have to do this. We just say if a list, hold on, what is my criteria? So every time I have a new one, so so if pre-x is none, or pre-x is not equal to wrapper.x, right? This is when we going to get a new one. So when I say list is, so when I do previous list, when I push the previous, I have the previous list. So if list, when I say res.append list, and then list equals a new one. Yeah, if it exists, then we push this in, and I'll create a new one. And after we create a new one, we always append. So I'm gonna do list.append the new wrapper.value, and then I'm gonna return this. Okay, so that's pretty much it. Include the wrapper as well. Let's see if it works. I don't need all this. Let's see. Tree node has no. Oh. Wow. Wow. Why do you do value? I don't understand. Yeah, I called wow. Huh. Not what I had expected. Oh! Huh? What happened? 15. Where's 15? Where did 15 go? Why I did 3 twice? Alright, I have to do this type of debugging. I absolutely do not like it. But we have to. I have to print a PQ just to see how it looks like after traversal. To make sure that it's correct. Oh my goodness. I think it is this. All we need is just turn self.val, self.x, and self.y. Oh, gaudy monstrosity. Has to be a string. My bad. I did not do it. So this should be fine. Oh man. Alright, is that correct? So when you pop out 9, pop out first. 3 got pushed twice. Why is 3 got pushed twice? Because I started with this. There we go. Okay, we got this right. When we pop out 9, pop out. And next, when this pop out, we'll compare. So 15 does pop out right afterwards. But why is 15 its own? So the first pop out is 9. So we probably, let's just do it here. So while this first, and it'll be easier to visualize. Print one here, and then after pop out, we start printing. So initially is this. First pop 9 is pop out, that's fine. Next one's 3, next one's 15. Good, because you did not update pre-x. Because you did not update pre-x. So we need to update pre-x equals wrapper.x. And I think this way we have it. What is this? I got this in, but I missed 7. Because I did not do it one more time. So so the last one is 7, right? 7 got popped out. And currently pre-x should be for the 20. So we compare. Pre-x is none, or pre-x is not equal to current. So we go in, if list, good, so 20 gets pushed in, and this gets out, pre-x is the new x, comes out, and then going back, normal PQ, so we're gonna say res plus list. It's the last list, we have to put it in. Huh, cannot do it. Oh yeah, you cannot do it. You cannot, it has to append. Can we do it inside? So it's already out. I guess you cannot, so you have to go rest.append list. That's the last one. Don't like it. Let's do it this way. This one shall work. Yep. Alright, let's try some other test cases. I know the other test. Oh, no, not debugger. Let's do the other one. 1, 2, 3, 4, 5. No. 6, 7, 8. No. 10. It is not correct. Huh. Alright, what is wrong right now? So, 1, 2, 3. Wait, what? Alright, let's see if it's. So 7 got popped off first, that's right. And then 4. And then we have 1. No, it should be 2 because 2 has a smaller x. 2 has a smaller x. Why would 1 get popped off first? It's 3 minus 2. If self.x smaller dot other dot x, then turn true. Yeah, so we compare x first. And here the x tells me that this one popped first. Why will be this one gets out first? Hey, what's the reason behind this? If you're saying that x is smaller than other dot x, that's interesting. I need to check the magic method. To use the less than sign for an object. Hold on. Self plus change the behavior, okay. If those objects of the matching method defined. Comparison. So x dot, okay. So we call this if it's smaller. All right, what's the documentation for this? Yeah, we call x dot this y. That's exactly what we're doing. We call wrapper dot, so we compare these two. So if it's smaller, then we return true. We should return already here. Well, the priority queue is not correct. Why? Why is the priority queue not correct? So it pops 7, 4, and then it popped 1 out. It put 1 into the priority list. And then this 2, and then it's 3, and then it's 8, and 5, 6, 10. Is it like it cannot handle negative number? Didn't seem to be. Why would it not able to handle negative number? That does not make any sense. If x is the same, then we compare y. If y is the same, we compare value, right? That's the correct order. Why it's not? Okay, this is very weird. Because behavior-wise, this is correct. It gets the smallest here, and this is also correct. And just after this, heap pop. It's just popping weird stuff. It popped 2, and then instead of pop 8, which is supposed to be, it pops 3. Why does it not pop 8? Alright, maybe I used the heap queue wrong. Let's take a look at heap queue. I cannot believe I used it wrong. I have used heap queue before. Heap push, heap pop. Pop return the smallest item, maintaining the heap invariant. Yeah, it does maintain the heap invariant. We maintain the heap invariant. It's very weird. Okay, I want to write this here and then you know, write this here, and then we do just a little bit experimentation. Yeah, let's just do some experimentation on this. It just doesn't make any sense. It does not make any sense to me. We have the wrapper, right? So we say here's this, and wrapper, let's just call it, let's just make a little bit change, right? Let's just call a val. So we basically put these in, right? So we're gonna say this, and then heap q dot push, heap push, right? Heap push pq, and put a wrapper. Same thing, 7, say -3, -3. And then I'm going to put 4, -2, -2, 2, -1, -1, 1, 0, 0, 8. Hold on. Nope. Nope, 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 nope. Just trying. Just trying. This next one's 5, 0, 2, 10, 1, -3. So it's 3, 1, -1. The last one is 6, 2, -2. So I'm push all this and print. So while pq pq dot heap heap q dot heap pop pq, and then I'm going to print pq. And also print pq initially. So let's just see. So the first thing I also need to print. Let's print this one as well. Print this. Kind of see which one is. Hold on, what do we do? So we don't need to print this. Let's just do this. Oh, I need to print this. Wow, this is even more wrong. How is this possible? 1, 2, 3, 1, 2, 7. This is not even the same as this one. Heap q dot heapify heap q dot heapify. No, it doesn't really help at all. The first thing pop out is 1, 0, 0, and here the first thing pop out is 7 -3 -3. What is the problem here? All right, let's do it this way. Let's just do it based on x. Okay, it's correct. Just based on x is correct. What if we do like based on x and y? Now we are not correct. What does this mean? I think we're tapping into something even more serious. Like if we do this, then the order is not correct. It doesn't come out. The -3 doesn't come out. It's like this one is the first to come out. Hold on. Let me think. What we're trying to say is, if self.y is larger than the other one, so if it's the same, then we shouldn't hit. Should we? Because I say if this is smaller than this, and then return true, and then it's not, right? They compare these, and then it's not, and then compare the y, and then the y, my y is larger than yours, but if it's equal, if my y is equal, then we have an issue. We don't know what to return. I think that is the issue. So instead of doing this, so basically we're gonna say they do this smaller than self.y. No, it's the same thing. It's exactly the same thing. It is when, oh, it's this is because we have situation where x is the same, so that we have x is the same, and then we have to compare y, and then y, but if it's x the same, then we don't need to compare anything else. It's like if we do this, then this should be, yeah, this is based on y, and then we do this, it is based on, it's almost based on y, but we have -1. Why would you want to base on y? I already said if it's x, then we do this. Elif? No, it doesn't make any difference. Alright, this is something that I need to ask Stack Overflow. This is something with the Python implementation of the priority queue, I guess. I can't get this to work. Alright, this is something I have to check. I'll have to check the Stack Overflow. But anyway, this method is not working right now. I'll get an update tomorrow. Alright, that's it. It's enough for today.